Good day, everyone. I am SANTOS together with Ms. Camino, and in this video, we will discuss about suspension and its physical-chemical properties. Pharmaceutical suspensions.
Suspensions may be defined as preparations containing finely divided drugs particles distributed somewhat uniformly throughout a vehicle in which the drug exhibits a minimum degree of solubility. Some suspensions are available in ready-to-use form, that is, already distributed through a liquid vehicle with or without stabilizers and other additives. A powder mixture containing the drug and suitable suspending and dispensing agents to be diluted and agitated with a specified quantity of vehicle, most often are purified water. Drugs that are unstable if maintained for extended periods in the presence of an aqueous vehicle are most frequently supplied as dry powders mixtures for constitution at the time of dispensing. Next.
Suspension have different dosage forms and administered via oral. Next slide, please. Topical, parenteral, ophthalmic, and rectal. Next slide, please. Relevant physical-chemical properties of the dosage form. These pharmaceutical suspensions are aesthetically pleasing and have a pleasing odor and taste. Liquid dosage form with poor palatability may lead to non-compliance, especially among children. Pharmaceutical suspensions having a pleasing odor and taste as part of the strategy can improve patient adherence. Second, all of the doses dispensed from a given multi-dose container have acceptable drug content uniformity. It is important to ensure the uniformity of the drug content in a multi-dose container to make sure that the strength or sterility of a therapeutic drug is within the specified acceptable limit. Third, suspensions are manufactured using a high energy mill to disperse the insoluble powder ingredients in the suspension vehicle. Ball mill, specifically the small or average ball mill, is used for grinding drugs or suspensions, which produces a very fine powder not less than or equal to 10 microns. The size of the particle affects the bioavailability. The smaller the particle is, and it increases surface area and the higher rate of dissolution and solubility. Next slide, please.
Fourth is chemical forms of certain for-tasting drugs have been specifically developed for their insolubility in a desired vehicle for the sole purpose of preparing potable liquid dosage form. For example, erythromycin acetylate is a less water-soluble ester form of erythromycin and is used to prepare a potable liquid dosage form of erythromycin. The result being is erythromycin acetylate oral suspension. The fifth is the greater the density of the particles, the greater the rate of descent provided the density of the vehicle is not altered. Because aqueous vehicles are used in pharmaceutical oral suspensions, the density of particles is generally greater than that of the vehicle, a desirable feature. If the particles were less dense, the vehicle they would tend to float, and floating particles with it would be quite difficult to distribute uniformly in the vehicle. Sixth is the rate of sedimentation may be appreciably reduced by increasing the viscosity of the dispersion medium, and within limits of practicality, this may be done. However, a product having too high a viscosity is not generally desirable because dispersed with difficulty, and it is equally difficult to disperse the suspenside. So the last and this is the physical stability of a pharmaceutical suspension appears to be most appropriately adjusted by an alteration in the dispersed phase rather than through great changes in the dispersion medium. In most instances, the dispersion medium supports the adjusted dispersed phase. These adjustments are concerned mainly with the particle size, uniformity of particle size, and separation of the particles so that they are not likely to become greatly large to or to form a solid cake upon stunning. That's all our report. Thank you everyone and God bless.